Okay, good morning for us too. Alright, before we start today's lesson, okay, let's just do a quick recap of what you learned yesterday. Right, remember yesterday we started on chapter 15, rates of change, and we learned that, alright, if dy over dx is more than 0 for a particular range, alright, we can say that the function is actually an increasing function. Right? And if dy over dx is less than 0, okay, then from yesterday we learned that we can show that the function is a decreasing function. So in essence, alright, dy over dx, okay, actually shows the rate of change of a function. And if we were to actually look at it further, it actually shows the rate of change of, okay, since it's dy over dx, it's actually the rate of change of y with respect to x. Okay, that means that if I look at the function as, alright, a result of y with respect to x, I'm looking at how fast y changes with respect to x. Now, if we have t, which represents time, and we want to show dy over dt, then similarly, dy over dt also shows the rate of change. But because of the difference, okay, this is dy over dt. So it actually shows the rate of change of y with respect to time. Okay, so what this means is that basically it tells you how fast y is changing with respect to time. And if you have dx over dt, it shows you the rate of change of x with respect to the time t. So basically dy over dt and dx over dt is telling you, okay, when t is changing, for instance, when t increases from 1 second to 2 seconds, how fast is y changing and how fast is x changing. Okay, so if you were to look at this in this perspective, okay, basically dy over dt tells us, alright, in 1 second, alright, or in a certain number of seconds, how fast y is changing. And dx over dt will tell us how fast x is changing with an increase in time. So the next question you may ask is, okay, I have dy over dx, I have dy over dt, and I have dx over dt. So how is everything related? Okay, we can see that actually dy over dx is equals to dy over dt times dt over dx. Okay, so it's as if though you're multiplying, okay, as if though you can actually cancel out the dt and you get dy over dx. And, alright, dt over dx is actually equals to 1 over dx over dt. So it's the reciprocal of dx over dt. Or another way for us to put it is that dy over dt is equals to dy over dx times excuse me, dx over dt. Okay, so it's as if though you can cancel out the dx and you're left with dy over dt. So we will be making use of this, okay, to help us to solve questions, okay, that are related to rates of change with respect to time. You realize that over here, okay, this is really, we're talking about rates of change with respect to time. Okay, so we will use an example to help us to see how we can actually, alright, apply this, and after that you can actually work on your own.